It has to be my voice. You realize that, right? My phone recognizes my voice. So when I say, it gets very sensitive.
You say what, Miss Woman? I can't hear you.
Okay, we're going to learn 2 tests today.
Integral. Oh,
The first is the integral test. What do you think it involves?
Derivatives.
No.
What did you say?
Eating.
Joseph, no.
I'm not sure what's happening.
Casual.
Now, with our telescoping series and our geometric series, we did know what our series converged to if it did converge. However, the integral test will only tell us if it converges, not what it converges to.
That seems kind of not useful. I have to agree with William.
What did she say?
Doesn't seem useful. I mean, what can we use it? You're gonna tell us.
How about the other one we learned today? Is a follow-up to this one?
It is.
Gave your.
It's a shortcut. That's what I
Okay, what if it starts at n equals 2? Do you just set the limit to 2 instead of 1?
That is an excellent question because we will see something like that. Joe just asked, what if the series starts at 2? Do you set your limit of integration to be 2? Yes. Yes, you do.
Okay, that makes sense.
Okay. Now, I will be pretty particular when you use this test. You better show me that you thought about it being positive, you thought about it being continuous, and you show me that it's a decreasing sequence. We don't have any ways to show decreasing sequences, do we?
Derivatives.
We have 3 ways. We have the derivative test. Oh, I have
Those are three.
We have the ratio test and the difference test. Which one really was more enjoyable for you? This was like Friday, wasn't it? Thursday? Thursday.
Ratio test, difference test, derivative test.
Okay. More than likely you're going to use the derivative test because, well, we like derivatives better. Okay? So here is our infinite series.
Okay.
Okay. If we are going to use the integral test, then we need to think about the function e to the negative x. And we need to determine, is this a positive function? We can think about the graph. Yes or no?
Yeah.
Okay. Can you take e to a power and get a negative number?
No.
Okay. Is this a continuous function?
Yeah.
Yes. Okay, and then is it decreasing? You're going to prove to me it's decreasing. So I say we take the derivative because e to a power is like the easiest derivative rule we know. The derivative would be negative e to the negative x. Negative e to the negative x. I have no idea what I was trying to say.
So yes, it's always decreasing.
Said it backwards. It is always negative, which means our function is always decreasing. This is kind of the annoying part about the integral test is you first have to show me that those things happen. Now we can look at the integral. So since we have the sum from n equals 1 to infinity, we are going to look at the integral from 1 to infinity of e to the negative x dx. Okay? back in chapter 8, we talked about all of our integration rules. This is an improper integral, so we're going to change it to a limit. Then we can take the antiderivative. So we have the limit as a approaches infinity of negative e to the negative a minus negative e to the negative 1. Negative e to the negative a. What does that approach as a approaches infinity?
0.
So our integral is 1 over e. Since we have a value, we know that our integral converges. And if our integral converges, then our infinite series converges by the integral test. I mean, if you put the symbol, I'll take it. If you're looking for some shortcuts to save some pencil lead.
Couldn't we also just have used the geometric rule for this one?
Oh, yes. Could we have done that?
Yeah.
Isn't this just 1 over e to the n? And 1 over e is less than 1. So we could have said that it converges geometrically because r is less than 1.
Well, now figure out what it converges to.
And we could figure out what it converges to. Now, here's the beauty of these tests. Okay? Maybe you didn't recognize that you could manipulate the series to be geometric. We still used a different test, and were able to conclude that it converged a different way. Okay?
Isn't it just a geometric series already?
It is, but it's not written exactly, like it's not written in its geometric form, right? Because it has a negative n power instead of a positive n power. So what I'm saying is if you didn't recognize, nobody stopped me.
Oh, okay, you'd have to do it as 1 over e.
I was like, test is doing it.
Okay? Some of us might not have recognized that this was geometric, but we used the integral test, so it was fine. Okay?
Wait.
Would you like to look at one that you have to use an integral test on no matter what?
Wait,
I feel like it would
isn't
help.
e greater than 1?
Yes.
1 over e is not.
Oh, okay, that's right. It's 1 over e. Integral time.
Why did you have to ask him to start it at 2? Because she was like prepared for that.
That's why I said it was a good question.
No,
Because now we don't have to assume.
Why does this one have to start at 2?
because you want to make it
Because
hard.
you don't want the first term to be 0.
Yeah, that would be kind of silly, right? 0 plus. Okay, so yes, we could have done the geometric series test on this guy. We didn't. You might be mad at me. You'll get over it. This one, you have no choice. You have no choice. Even when we get our other tests, this one is set up to where you really can only use the integral test. Okay?
Are we going to be able to find where it converges that? Or
What'd you say?
Are we going to be able to find where it converges that ever?
What do you mean where?
Well, you just said that the integral test would only tell us if it converged or diverged.
Right. We will not know where it converges to. We'll just know
Will
if
we ever know that though? Like, is there another test that will enable us to do it with this particular problem? that kind of.
Like this one?
There's
Not, well, we'll be able to get like a radius. Yes.
Can we use the integral test on this one? Because it's not continuous and clear. Or can I do that one?
Well, we're going from 2 to infinity.
So it doesn't matter.
Exactly. So we're going to look at f of x equals the natural log of x over x. Okay? We know that anything we put into here from 2 to infinity will have an output that's positive. Since our domain is 2 to infinity, we can say that it's continuous because 0 is not a part of our domain. And then decreasing. This is always the joy.
How do we do the derivative of this one?
Well, it's quotient. So the derivative of the numerator.
It's 1.
What?
Oh, it's 1 over x.
Is 1 over x times the denominator x would be 1 minus the numerator times the derivative of the denominator all over the denominator squared.
Fancy.
Is that going to be a positive derivative for 2 to infinity?
No.
Is it going to be positive after e?
Yes.
Okay. If I plug e in here, we get 1 minus 1. So this is positive for x greater than or equal to e. We begin at 2. E is 2.7. So this is eventually decreasing. So we're safe. Okay. We're safe. What's the matter, Gabe?
Wait, allergies are the matter.
Oh, I thought you were upset at this. Okay.
But it starts increasing after 2, so
No.
when it diverge.
Sorry. Why do I keep making the wrong sign? Less than. Because after e, this is going to be a number bigger than 1. So it's going to be less than 0.
Oh.
I'm sorry. I did it on the last slide too.
That makes sense. Yeah.
Okay.
That one.
Okay. So now we get to have our fun with the integral from 2 to infinity of the natural log of x over x dx. Would you like to use a again?
I should ignore it.
How are we going to do the antiderivative here?
Isn't it just the natural log of x squared? Or, no, wait.
So u is the natural log of x. Du would be 1 over x dx. So essentially, we have the integral of u, right? Okay. Okay. So our antiderivative would be,
Natural log of x squared over 2.
yeah. So now we need to look at the limit. And you're going to see what I did here. I set up my u substitution. I put it right here. But then I think we've done u substitution enough. I know that the antiderivative is 1/2 u squared. So I just went ahead and changed it from 1/2 u squared to 1/2 natural log of x squared in my head. Is that okay? Gabe, you're okay with that?
Well, like, I feel like you ask now when that's very, very, very something I feel like you should all be okay with. And then on something else when we're explaining in class and I have no idea what's going on, you skip like 4 steps. So just, yes, that's okay.
Okay, I'm not sure whether that was a complaint or not, but we'll keep going. Okay, so if we evaluate it from 2 to a, we get this. And we have the limit as a approaches infinity. What happens to the natural log of a as a goes to infinity?
It becomes infinite. It becomes.
Man.
Can't say we didn't try.
So it diverges.
Oh, I'm not upset. Apparently I'm just writing very,
Aggressive.
yeah. A lot of passion. Okay.
You can't spell integral without anger.
Stop it.
Let's not spread that. We're about, next week is our integral test for AB. I don't think that I need any of that negative connotation.
Like, I heard kind of what you said.
You can't spell
Integral
integral.
without anger.
Man, I hope I'm gone next year. On this.
Another code word. Anger.
Code word anger.
Husband and daughter.
Wow.
I know, but that'd be.
Walks out.
Okay. How about, and we'll do this together. What test would you like to use?
Why don't we just use the limit test?
We don't know it yet. What test would you like to use?
Limit test.
The limit test.
Yeah, because 1 over infinity is 0.
Which tells us nothing. When it's not 0, it tells us it diverges. But when it equals 0, it tells us absolutely nothing.
It tells us that there's a chance that it can.
There is a chance.
Tells us stuff we know.
Thank you.
Let's
Okay,
do
so
the integral
next.
test. Let's do the integral test.
Oh.
That's what this lesson is.
Do we have a positive function?
Yes. No.
No.
Yes.
No.
Yes.
Wait, yeah.
Our domain is 1 to infinity.
Yes.
Yeah,
Okay.
so then
I
it's
was
positive.
like, wait a
Do
second.
we have a continuous function from 1 to infinity?
Yes.
Do we have a decreasing?
Yeah.
You need to show me that it's decreasing.
No, we're not this
Assume is my favorite word.
Negative 1 over x to the 4th. Oh wow, it's always negative.
How about negative 3 over x?
Oh, you're right. Negative
Okay.
3.
Okay, just want you to have all the facts, Joe.
Yeah, negative 3. Because you have to multiply by.
The power.
Should
Should I keep singing?
No.
Yeah, that'd be impressive, especially if this video goes to the barn school.
No, my husband's there today.
Tell him to go home. What hour do they have, Cal?
They have fifth.
Oh, lunchtime.
So just tell him to like not show up for that like 1 hour.
Yeah, go out for lunch with your husband. Wouldn't that be nice?
Then pack it in a main
It's just silent.
I'll see him tonight.
I really hope he sees the video.
So we're doing the integral test now?
We were always doing
You
that.
were always the integral.
Man. Okay, so I just want you to imagine how much fun we have in here during third hour. I used to have this class 7th hour.
Yeah. Peter and
Suffer.
Isaac
It was rough.
walked out. They wanted to hurt themselves.
Thanks.
It's just okay.
to the negative third?
Negative 1 over 2x squared.
I don't know.
Yes.
Like this?
Said that, I feel.
Yeah.
Okay, I'll accept
I'm
that.
still writing.
Not that good.
I just like how her face.
Yeah, that was a fun phase.
I hear somebody still writing, so I'm pausing for everyone to catch up. They're teacher trained.
So like you always hear
Eagle
Gabe.
vision.
Yes.
It's okay.
Are we ready?
You're sweet. We're almost there.
So we have the limit as a approaches infinity of negative 1 over 2a squared minus negative 1 over 2 1 times 1 squared.
Well, what does A go to?
If a goes to infinity, what's this limit right here?
It means it's
Okay. So our integral converges to 1/2.
Why does that
Wait, I
have
thought,
some value?
I thought that it would tell us where it was.
Correct.
It
The
Oh.
integral converges to 1/2,
See, I'm
which
just
means
gonna
the series converges, not necessarily to 1/2.
But maybe.
Sounds for you.
Thank you.
I do want you to write converges or diverges with your integral so that you can talk about the series in the next thought.
So we have to state both the integral and the series.
Because that is what our theorem says. If the integral converges or diverges, then the series will do the same.
fascinating.
It's a really
Guess what, ladies and gentlemen?
test.
Oh, test 2 times.
What did you just say?
It's a very nitpicky test.
It's a nitpicky test, and it takes a long time, doesn't it?
Uh-oh.
If it's in this form, we have a shortcut.
Woo!
Lovely.
If it's in this form, sorry. You have to use the integral test. Why this form? If we have 1 over n to the p, it is what we call a p series.
T series.
P.
I'm confused.
Nope.
So this is our 5th test.
Okay.
We're gonna take it back turn.
You only get you the one that was home and I can.
No, I really don't want to be in your
What if P is like a decimal?
You're welcome.
Just a moment, Joe. We talked about this the other day. 1 plus 1/2 plus 1/3 plus 1/4, etc., etc., etc. That is called the harmonic series. You don't have to write that down, but that's just a little fun fact. Okay. The P series, and if you think back to our integrals, now some of you saw some patterns with our integrals. You remembered that 1 over x cubed and 1 over x squared, those all converged. Do you remember our integral from 1 to infinity of 1 over x? It didn't converge, and that was kind of strange to us. Okay? What happens in our P series test, test number 5, this is like even easier and quicker than the geometric.
Ooh, that's good.
Right? But it's super specific. It has to be 1 over n to the p.
Which there's like not gonna be one of those in the test, is there?
I should write out all the rules.
If P equals 1, what happens to our integral?
It diverges.
Okay, so then our series will also diverge. If P is less than 1, it also diverges. So in order for a P series to converge, P needs to be greater than 1. Here again, we are not going to be able to tell what it converges to, but we will be able to say that it converges. Yes.
Why is that not also a geometric form? Oh wait, because it's not to the end. I don't know what I was thinking. For some reason, I was like, you can take the part out.
So it's kind of the backwards,
Yeah.
right?
Yeah.
So it's the n to a number power as opposed to a number p in power.
Yeah.
If the numerator is not equal to 1, does it change how it works?
Yep. I'll show you an example of that.
Oh,
It's like
no.
you have the coefficient of
If you have like 5 over n cubed, can you take 5 outside of the summation?
Yes. That's a rule.
That is a rule.
Ruler.
We wrote it down on Friday. You know what the rule that I think you were thinking about with the multiplication was for sequences, not
Yeah.
for series. Okay, so you writing it down is going to take longer than us talking about the answer. Is this a P series?
Yeah.
You betcha.
Subscribe to. Wait, it's P series.
So this is a P series.
They did a fusion.
And P, how does P compare to 1?
Right here. Wait, do I have to write converges because of the P series?
Yeah, you have to write all of that. Like I said,
It's P series because P is.
you're going to have to do some writing in this chapter.
Lots of extra thoughts.
I'm not even making you write a sentence. I could make you write, the series converges because of the
I would
series,
enjoy
where P is greater than 1.
How it's written.
I'm not. Oh, subscribe to.
Write it down.
Wait a second. That's
I don't know how to do that.
divergent. I'm going to the margin. I really think I
You can factor the n out to get radical.
No, you cannot factor the n out.
It's a math joke.
Okay.
It's like a joke where it's radical 2 over 2 and someone takes the 2 out and Einstein just goes crazy. Like he's very angry.
How could we rewrite this? So how about 1 over n to the 1/2? So we have 1 over n to the p. If you can write it as a p series, go ahead and rewrite it as a p series, because then it's simple. This diverges because it is a p series where p is less than or equal to 1.
That's a really fast test.
Less than or equal to the top line of your equal sign is like perfectly straight.
Oh, but not the bottom one. Last year, remember my perfect
Yeah.
equal sign? Yes, I haven't had one since. That was close, though. Okay, well, there you go. There's your homework. What does EOO mean?
Every other
Every
hour.
other
So
Which is upsetting.
Evens
because it's
only,
like
obviously.
1, 5, 9.
Evens
It's
only.
not 11.
if you don't,
Which one of us
if
one
you
of
do
them
odd,
just-
Jackson, you might need to take a break from making comments in class.
Wait, why is it 1 through 11?
You can't
Do
spell
every
integral
other
without
option is
anger.
25, 9.
That's what I said.
Even as only.
Why is it 1 through 11? Because you only end up doing